This lecture continues in section 2.7, where we're now going to talk about the elasticity of demand as it relates to calculus. How we're gonna solve it and find the elasticity of demand for some situation in our calculus class. So it just goes like this: the elasticity of demand E is given as a function. So it's going to be some function of the variable x, where x is the price of the item. Okay, so if you look back, in the previous slides or previous video lecture here, we talked about the elasticity demand of some good, some item that's being sold. So this quantity, this value, this variable x is the price of that quantity, and it's just given as, so the elasticity of demand, E of x, is equal to negative x times d prime of x divided by d of x. All right, well, what is d of x? So this is where d of x is the demand function for the good, for the item. And this demand function is also a function of x. Okay, so this demand function is also a function of the price. All right, so let's do an example just so you can see how this all works out here. Okay, so here's the silly example. So we have Clicks Candy has found that demand for its candy bars is given as the following. So Q, the quantity demanded, is equal to D of x, and it's equal to 120 minus 20 times x. Okay, so they make let's just call it like this high-end candy bar, where they only produce a small number of them per day. Okay, so this is where Q is the number of candy bars sold per day at X dollars per candy bar. Okay, so we want to find all the following. The first one, pretty easy. We want to find quantity demanded when the price is $2 per candy bar. The next one is we want to find the elasticity of elasticity as a function of x. So we want to find, just going back real quick, we want to find this right here for this example. Then we want to find part C, the elasticity when x is equal to 2 and when x is equal to 4. And then what we're going to do is we're going to interpret that value, interpret the meaning of these values of the elasticity. D, we want to find the value of x for which elasticity is equal to 1. So that's perfect elasticity. And then we want to interpret the meaning of this price. E, we want to find the total revenue function. So I'll go through how finding that. And then F, what we want to do finally is we want to find the price x at which total revenue is maximized. Okay, so let's go back. So right off the bat, first thing we want to do is, in part A here, is we want to find the quantity demanded when price is $2. Okay, so we want to find Q, quantity demanded when price is $2. Well, what you're going to do is you're going to take this and plug it into the demand function. It's pretty easy, right? So this is 120 minus 20 times x, while we're plugging in 2. So this is 120 minus 40. So what this is saying is at $2, demand will be 80 candy bars. Okay, that's pretty easy. All right, next part, B. Let's find elasticity as a function of x, as a function of price. All right, so what you're going to need to do is you're going to need to use this. It's minus x times d prime of x divided by d. Okay, well, again, that's just x times negative x times d prime of x over d of x. Well, this is negative, and then x. This is pretty straightforward here. D prime here, so the derivative of the demand function, it's just negative 20 divided by 120 minus 20x. Okay, so just so we're clear here, what ends up happening, negative, this ends up being 20x divided by 120 minus 20x. So I'm going to factor out a 20 of the denominator. You're left with 6 minus x. Notice 20 cancels here. And our elasticity as a function of the x variable, which is price, is just x over 6 minus x. Okay, next part. Let's go find C. Let's find what the elasticity is when x is equal to 2 and when x is equal to 4, and let's interpret the meaning of both of these values. Okay, what they mean in terms of values of elasticity. So first let's find E of 2. Okay, so this is just 2 divided by 6 minus 2. I'm literally just plugging this into the elasticity function I just found. So this ends up being 1/2. Okay, so what this means is elasticity is 1/2. Okay, so the elasticity here, so it's less than 1. Okay, so when you look back here, what does that mean? So just going back, that means we have price elasticity demand is less than 1. It's inelastic. Okay, so we have inelastic demand here at this value. Okay. Inelastic demand, just going back here. Sorry about that. Inelastic demand. All right, so what this means here then is a small percentage increase in price, okay, will cause an even smaller percentage decrease in quantity. Okay, that's what that means here. So for this price point here, this small increase in price will cause an even smaller percentage decrease in quantity. So what that means is consumers aren't responding in the same proportion into this price change. Now let's do the same thing for E of 4. So here now you end up getting 4 over 6 minus 4, which is 4 over 2, which ends up being 2. So I won't go back in the slides here, but what this means is we have elastic demand because it's greater than 1. And so what happens then is when you have a small percentage increase in price, what will happen, it will cause a percentage decrease in quantity demanded that exceeds the percentage change in price. Okay, so I know this is a little confusing, so let me just try to explain this in layman terms here, what's going on. So when the candy bar only costs $2, what this means is consumers want it. Okay, they're like, yes, I want to buy this candy bar. So if you raise the price like just a little bit, okay, you're not going to see that big of a decrease drop in demand. Okay, at $2. But now all of a sudden the candy bar costs $4. Okay, so if you were to change the price even just a little bit more, consumers would be like, wow, candy bar is already $4. That's it. I've had enough. Demand's going to drop much larger percent change than you change the price. Okay, so like in the first case here, it would be like if I raise prices 1%, we'd see demand fall by a fraction of 1%. Where down here is if I was at $4 and I change the price even just one more percentage, demand's going to fall by more than 1%. That's what that means there. Okay, so the next one, D, it says let's find the value of x for which E of x is equal to 1. So to do that, you're just going to take that function you had, that x over 6 minus x, set it equal to 1 and solve. So, you're just going to cross multiply. You get 6 minus x is equal to x. Add the x over, divide by 2, and you get x is equal to $3. Okay. So what this means here is when the price is $3, the ratio of the percent change in quantity demanded to the percent change in price is 1. It's perfect. So what this means at that $3 mark, it's like if I just raised it 10%, demand would fall 10%. That's what you're seeing here. Okay, let's find the total revenue function now. How do you find total revenue? We're going to have this be a function of the x variable. And what this is equal to is you just take the price of the good and you multiply it by the quantity demanded of the good, how much you're selling it for. Or how much you're selling it for, excuse me, times the demand for it at that price. Sorry about that. So that's x times 120 minus 20x. Well, you can see that this is just 120x minus 20x squared. That's the total revenue function. All right, so then once you know the total revenue, as a business, the last thing you might want to do, obviously, is maximize total revenue. So let's find the price x at which total revenue is a maximum. So find price that maximizes total revenue. All right, so R of x was 120x minus 20x squared. So to find a max, you need to take the derivative, right? So the derivative of this function, the derivative of 120x is 120. Bring the 2 down, minus 40x. Next thing you're going to do is find critical values. So you're just going to set this equal to 0. So to find the critical values, you're going to have to solve 120 minus 40x is equal to 0. And you just with some simple algebra here, you can obviously see this is x is equal to $3. Okay. Which is interesting because you notice that's also where elasticity is equal to 1. That we'll talk about that in a follow-up example. Why that is. So next you can see, just to verify, to make sure this is a max, if you look at the second derivative, it's just minus 40, which is less than 0. So what you can see here is total revenue is at a maximum when price is equal to $3. All right, so that was just a first quick example to this topic here. I'm going to follow this up with another example next when we talk a little bit more about elasticity, the values that maximize profit and revenue, and we'll follow it up.